affecting glass transition temperature Tg. First is the chain flexibility. In increasing the chain flexibility, glass transition temperature will be reduced. Steric या bulky group. The steric या bulky group in increasing the steric या bulky group, the rotation and chain flexibility of the polymer. Chain flexibility of the polymer is reduced. Rotation reduced, that's why their glass transition temperature is increases. Geometric या configuration effect. In this effect, the cis and trans configuration are the considered. We can discuss its following. Polarity. The polarity of the polymer is increases, then their intermolecular forces is increases. That's why their rotation will be reduces and chain flexibility also reduces, so that their glass transition temperature will be increases. Molecular. The molecular weight of the polymer. The glass transition temperature is directly proportional to the molecular weight of the polymer. So, increasing the molecular weight of the polymer, the glass transition temperature of the polymer is also increased. Plasticizer. The plasticizer is added to the polymer to improve their flexibility. So, increasing the amount of the plasticizer, the flexibility of the polymer is increased. That's why the glass transition temperature of the polymer is decreases. Cross-linking. The cross-linking is the important factor in the thermoplastic polymer. Increasing the cross-linking in the thermoplastic polymer, their chain flexibility is reduced. That's why their glass transition temperature will be increases. The same, the crystallinity. The degree of the crystallinity with the increases, then the ordered structure of the increases, so their glass transition temperature will be increases. The co-polymerization technique. The co-polymerization technique is the powerful technique to use to control and modify the glass transition temperature of the polymer. The co-polymerization technique for the TG we discuss below. The cyclic structure of the polymer restricts the rotation of the backbone of the polymeric chain. That's why their flexibility will be reduced, and so their glass transition temperature will be increases. Glass transition temperature of the PET is around 67 degrees centigrade, and glass transition temperature of the PBT around 40 degrees centigrade. You can see the glass transition temperature of the PBT decreases because of here you can say this group are the same in the both polymer, but this group is the known as aliphatic chain length. And in a PBT we can see the aliphatic chain length is the greater than aliphatic chain length in the PBT. So here the increasing the aliphatic chain length increase their flexibility, and that's why their glass transition temperature will be reduces. Geometric factors such as the symmetry of the backbone and presence of the carbon-carbon double bond on the main polymeric chain affect the glass transition temperature. The first effect, the polymer chain having the symmetrical structure have lower TG than a symmetrical structure. For example, so you can see here the symmetric structure in the polyisobutylene. So the glass transition temperature of the polypropylene around -10. Yeah, in some book we can see -20. The polypropylene of the glass transition temperature of the polypropylene is lie between -10 to -20 to -10 because of the polypropylene is found in the three form. One is the isotactic PP, syntactic PP, and atactic PP. The isotactic PP, so the glass transition temperature is -10, and atactic PP is the so glass transition temperature is -20, and syntactic PP, so the glass transition temperature lie between -10 to -20. So, and in polyisobutylene we can see here is the symmetrical structure about the carbon main polymeric chain. So their glass transition temperature is the -70 degrees centigrade. So you can see here the polymer having the symmetrical structure have lower glass transition glass transition temperature that of the polymer have the asymmetric structure. Third is steric या bulky group effect. When increasing the bulky group, when increasing the size of the bulky group, the rotation of the backbone is restrict. That means the rotation decreases. That's why the flexibility of the polymer is reduces. So the glass transition temperature of the polymer is increases. Remember this. In the steric या bulky group effect, the bulky group या steric group is increases the rotation. This bulky group restrict the rotation. That means rotation will be decreases. And due to the restriction in the rotation, the flexibility of the polymer is decreases. So the glass transition temperature of the polymer is increases. For the example, the polyethylene, polypropylene and polystyrene. You can see the polyethylene. In the polyethylene, no bulky group, so their glass transition temperature is minus 126 degrees centigrade. But in case of the polypropylene, you can see here is the bulky group CH3 that restrict the rotation of this carbon-carbon bond. That's why their glass transition temperature is the minus 10 degrees centigrade. In case of the polystyrene, the repeat unit of the polystyrene is, you can see here the bulky group, the size of the bulky group is increases. That's restrict the rotation of this carbon-carbon bond. That's why their flexibility will be reduced. So their glass transition temperature is around 100 degrees centigrade plus 100 degrees centigrade. The polarity of the polymeric chain is increases. Then the intermolecular forces between the chain is increases. That's why their flexibility will be reduces. That's why their glass transition temperature is increases. So the polarity of the polymer increases. That increase the intermolecular forces between the two polymeric chain and that restrict the rotation of the backbone of the polymeric chain. That's why their flexibility will be reduced. So the flexibility will be reduced. So their glass transition temperature will be increases. For the example, CH3 is the non-polar compound. So it does not show the polarity. So their glass transition temperature around minus 10 degrees centigrade. But chlorine atom is come under the polar atom. That's why introducing the chlorine atom in the repeat unit of these increase their polarity. That's why their glass transition temperature is 81 degrees centigrade. Some book we get the glass transition temperature of 87 degrees centigrade. So don't confuse. You can see the both value are the nearly approximate nearly. So you write 81 and 87, both are correct. The pen polyacrylonitrile. The CN group is also come under the polarity atom, and the polarity of the CN atom is the greater than chlorine. That's why the polarity effect of the pen is the greater than PBC. So the glass transition temperature of the pen around 115 degrees centigrade. You can see here the increasing the polarity of the atom, their glass transition temperature will be also increases. The molecular polymer also affect the glass transition temperature of the polymer, and glass transition temperature of the polymer is directly proportional to the molecular weight of the polymer. Simply you can see in the graph. This is the Tg and this is the molecular weight of the polymer. You can see increasing the molecular weight of the polymer, the glass transition temperature of the polymer is increases. At a certain limit, the glass transition temperature does not affect on the molecular weight of polymer, and that time temperature at that time is known as the Tg infinitive. So the empirical relationship between the glass tension temperature and molecular weight of polymer is given by Tg. Tg of the polymer is equal to Tg infinitive minus K divided by Mn. Here K is then remember this formula where K is equal to constant and Tg is equal to molecular weight of the polymer at infinitive. Can you see? The glass tension temperature of the polymer is infinitive. So the glass tension temperature of the polymer at this point. And Tg is equal to glass tension temperature of the polymer. The cross-linking of the polymer also affect the glass tension temperature of polymer. When increasing the cross-linking between the two polymeric chain, their backbone rotation are restricted. That's why their flexibility will be reduced and the glass tension temperature will be increased. Consider these are the two main polymeric chain of the thermoplastic polymer. When the induce the cross-linking between these polymeric chain and this polymer does not moment. These are the both two polymeric main chain. You can see here you can rotate at any time. But when induced the interlocking between the both chain. This is the interlocking between the two polymer. When can you rotate this type? This is the very difficult to the rotation. That's why their flexibility will be reduced and their glass tension temperature will be increased. When increasing the cross linking, the glass tension temperature of the polymer will be also increased. Then the empirical formula between the glass tension temperature and cross linking of the polymer is given by equation Tg minus T naught is equal to 3.9 into 10 power 4 divided by mc. Remember this formula where Tg and T naught are well taken in the Kelvin, where mc is equal to number of the molecular weight between the two cross-link point. This is the two cross-link point. mc is equal to number of molecular weight between the two cross-link point. Here Tg is equal to glass tension temperature of polymer and T naught is equal to T naught is represent the polymer that are the glass tension temperature of the polymer before cross-linking, uncross-link, the Tg of uncross-link polymer, where this Tg show the cross-link polymer. Plasticizer is also affect the glass tension temperature of the polymer. First know what is the plasticizer. Plasticizer are the organic substance of the low volatile that added to the polymer to improve their flexibility, extensibility and processability of the polymer. So the main motive of the plasticizer to added any polymer to increase their flexibility. When increasing the amount of the plasticizer in the polymer increase their flexibility. That's why their glass tension temperature will be decreased. By the help of the plasticizer, rigid polymer is changed to the flexible polymer. The better understand, for the example, let rigid PVC. When added some plasticizer in this, let us. This is the two polymeric chain of the PVC in which this is the chlorine atom. And introduce some this is the polar group and this is also polar group. This is the type of the plasticizer which is the nature in the polar, and this is the polar group, this is also polar group, and that's why they both are the attracted to each other, and when both are attracted to each other, when in individual PVC, this polymer chlorine atom is the total due to the polarity on only this chain. When the polarity force between of the chlorine is distributed in the both sides, this bond and also this bond, so this bond will be extended, and that's why it create this polymer main chain shifted toward it. And similarly here, when this polar group attracted to this Cl group, and the force between this bond is also distributed along here, so this polymer chain shifted here, and that's why this polymer chain shifted here, this polymer chain shifted here. You can see here a lot of the free volume are generated. If increasing the free volume, this polymeric chain is start get a lot of space to further their rotation. That's why increase their rotation, and increasing the rotation, the flexibility of the PVC also increases. That's why their glass incident temperature will be reduced. The co-polymerization is the powerful technique which is used to control or modify the glass incident temperature of the polymer. The calculation of the glass incident temperature of the homogeneous copolymer a compatible polymer is given by Tg is equal to V1 Tg1 plus V2 Tg2. Remember this formula for the homogeneous copolymer a compatible poly blend, where V1 and V2 is the volume fraction. Of the component 1 and 2 respectively, and Tg1 and Tg2 are the glass incident temperature of the component 1 and 2. Remember this formula only for the homopolymer या homogeneous copolymer a compatible poly blend. Glass incident temperature of the random या copolymer, random alternate copolymer. Let the glass Tg is the glass incident temperature of the copolymer, and Tg1 and Tg2 are the glass incident temperature of the component 1 and 2 respectively, and W1 and W2 are the wet fraction of the component 1 and 2. Then the glass incident temperature of the random या alternate copolymer is measured by using Fox equation. According to the Fox equation, the 1 upon Tg is equal to W1 upon Tg1 plus W2 upon Tg2. Then where W1 and W2 are the wet fraction of the component 1 and 2, and Tg1 Tg2 are the glass incident temperature of the component 1 and 2 respectively. Always remember glass incident temperature taken in the Kelvin. Then temperature taken in the Kelvin. Technique to determine Tg, glass incident temperature. The dialtometry. The use of the dialtometry also measure the glass incident temperature by measuring the specific volume. The refractometry also used to measure the glass incident temperature of the measuring the refractive index of the polymer. DSC is also used to measure the glass incident temperature of the polymer by measuring the specific heat of the polymer. The dynamic mechanical analysis DMA is also used to measure the glass incident temperature. These are the some technique by which we can measure the glass incident temperature of the polymer. The some polymer and their glass incident temperature, like the polyethylene have the glass incident temperature rounding -126 degrees centigrade. Polypropylene have the glass incident temperature either -10 या -20 depending what the type of the PP are the three type: isostatic, syntactic and atatic. PVC have the glass incident temperature rounding 81 degrees centigrade. The polystyrene have the glass incident temperature rounding 100 degrees centigrade. The polymethyl methacrylate The polymethyl methacrylate have the glass transition temperature surrounding 105 degrees centigrade. ABS. The acrylonitrile butadiene styrene have the glass transition temperature surrounding 115 degrees centigrade. The styrene acrylonitrile have the glass transition temperature surrounding 115 degrees centigrade. The cellulose plastic like cellulose acetate, cellulose nitrate and cellulose acetate butyrate have the glass transition temperature surrounding lie between 150 to 160 degrees centigrade. The glass transition temperature of the PET surrounding 67 degrees centigrade and glass transition temperature of the PBT surrounding 40 degrees centigrade. The glass transition temperature of the nylon 66 polyamide 66 have the surrounding 60 degrees centigrade and glass transition temperature of the polyamide nylon 6 polyamide 6 have the 50 degrees centigrade. The glass transition temperature of the polycarbonate surrounding 145 degrees centigrade and glass transition temperature of the polytetrafluoroethylene surrounding 100 degrees centigrade. The glass transition temperature of thermoplastic polyurethane surrounding minus 51 degrees centigrade. The glass transition temperature of silicon rubber surrounding minus 123 degrees centigrade and glass transition temperature of the polysulfone PSO surrounding 190 degrees centigrade and glass transition temperature of the polyether sulfone PES surrounding 220 degrees centigrade. The glass transition temperature of the polyphenylene sulfide surrounding 93 degrees centigrade. The glass transition temperature of the PEK polyether ketone PEK have surrounding 145 degrees centigrade. The glass transition temperature of the polyamide surrounding 275 degrees centigrade. The glass transition temperature of the polyether imide PEI polyether imide surrounding 217 degrees centigrade. Similarly, glass transition temperature of the polybutadiene surrounding minus 100 degrees centigrade and glass transition temperature of the natural rubber surrounding minus 70 degrees centigrade. Remember these some data of the glass transition temperature.